Good morning. It's the afternoon. Hello. Anyways, I'm talking to the recording. You guys are with me though, right? Okay, we got this 3.2. Surface area of pyramids, cylinders, spheres, and cones. Continues on from where we left off with 3.1. More areas. And they're a little more complex, that's all. We need a review of area first though, eh? So here's where we're at. Calculate the area of the following figure. Now this is not easy, as easy, right? Because if I look at it like this, it's two shapes. If I just looked at it what we had initially, you might think I don't have a formula for that. Can you do this as two shapes? The area of not a square, a rectangle, plus, what's that all about? You got to think things through twice. It's half of a circle. So if I take this, I'm going to just sketch in mine, and I'd advise you to do the same. You need to know the radius of that circle. Holy catfish, how do you find the radius of that circle? Because I don't give it. 180. 180 is the degrees. That's half a circle. But the radius is this line from here to here. But it's also this line from here to here, right? Or it's this line from the middle down to here. When I draw that, what do you think of? What's this distance from here to here? Like the radius is 2 times. What is that distance? You were right. What is it though? I think you're right because I think you're 75. How did he do that? 1.75 is the radius. He's already steps ahead. Well, let's just take a look then. We'll take this apart. So I'm going to take off a few of these extras here. I'll undo that. I'll lock this in place because I'll end up moving it again. Okay. Slow-mo today. Okay, there we are. That's good. So I want to have this here, right? Now, if I do this, I don't have that lined up very well. There we go. That's a half circle there, right? Everybody buys that? We really can think of this as two shapes. I'm going to talk about this shape here. I'm doing that on purpose. And this shape here. Right? Everybody buys that? Now you might want to just draw this like that. And say, and I don't know why this blue box is there, it'll eventually disappear. Does it make sense that this box here, not the correct term, the rectangle there, it's 3.25 and 3.5, right? Now, everybody's good with that? That one, we can find the area of that by multiplying, right? No problems? Let's do that then. Get you guys to do that. The area of a rectangle is, I'm going to put it down here too, like area. I'm just putting that little box there just so you know it's the rectangle. 3.5 times, and that's feet as well. I forgot to put the FT. I'm screwed with my board right now. 3.5 feet, 3¼ feet. And I'll wait for an answer that'll be 11-ish or something. Or is it 10? It's 11 point. Okay, 11.375. Now, 375, if you want to round it off to 11.4, I'm fine. But if you're a full mark person, and you're going for good marks, which you all should be, I wouldn't just say 11.375, you need a unit behind that. And you know how we were measured initially in feet? Foot squared, because you're finding the area, the square footage of that. little spot. So this is obviously not drawn to scale. I mean, it's drawn to a scale. It's not drawn in real life size. Now, remember this, okay, I'll wait. Yeah. Remember this portion here, the half circle, is 3.5 on the diameter, right? So Destin right away clued in and said, yeah, so the radius would be, what would this radius be here? Half of the full diameter, right? He said, I think the way he did it, he had the right answer, so 3.5 feet. Now I'm going to show it as a fraction, divide by 2. Get used to seeing it as a fraction. So the radius, did you do that in your head or your calculator? I don't really care. But did you do it in your head? Or, yeah? 100 or 1.75 feet. That's the radius. I'm saying that's the distance from the center to the edge. And that's the same as the center to this edge, right? In a circle, if I take a piece of string, which I have. Pardon? You don't get that at all? Okay. Tell you what, I'll do something right here with this piece of string. You won't see this on the recording. Out the class. You guys know what I'm talking about. I'm recording this. You noticed yesterday or the other day that I was watching a video of this. Okay. If I say this is the center of the circle, if this is 1.75 inches right here, oh, my thumb moved, but this is 1.75 inches here. Does that make sense? Now, a circle means, okay, my thumb moved, but you get the idea. This is the same distance from here as it is to here, because I haven't changed the string, have I? It's the same distance to here. Now, does that make sense? First of all, that's what a circle is. You just take a piece of string, put it on the center dot, swirl it around. That's what a circle is. You got me there, though? Like, you see it, though this distance hasn't changed when you go around. You don't know what's going on? Okay, well, we'll backtrack. Thank you for telling me right away. The worst thing you can do is just be quiet and say, okay, I'm ready. Because if you're not ready, you're not ready. That's the best thing to do. So I'm going to move this up, or out of the way. Now, when I demonstrated with the string, though, did you see what I meant by the circle is the same length from the middle to any point on the edge of the circle? That makes sense? What you're saying isn't making sense is what did I just do here with this r equals 3.5? No, do ask the question. Just what are you wondering? Yeah. Okay. I'm going to back up then and we'll see where you do. You understood that this big figure here is, okay, is basically a rectangle and a half circle, right? The half circle part. Okay, good. Does it make sense? And I'm going to erase what I wrote down here because it didn't make sense. Okay, get rid of that stuff. So this half circle I'm just taking out of the diagram. Now if I move this half circle though over here, what is the length of the flat side of the half circle? So that's 3.5. So I'm going to draw it a different way. This is 3.5 feet, according to the diagram. You're with me too? Okay. So then, I only want half that distance because by definition, a radius is the distance from the middle to any of the curved side of a circle. And I know that the distance from the middle down to here, just by looking at it, should be half of the full distance. So if you take the full distance, divide by 2, right? 3.5 divided by 2. You've got the radius. That's what I was finding. It does make sense now? Okay. That's important. Thank you for mentioning. So, the radius, I'm going to use green there, is equal to 1.75 feet. Why do I need that? Well, first day, the first page, you had a formula for the area of a circle, right? And that's on the front of this page. I'll tell you what the formula is. The area of the circle, if that was a full circle, you'd say the area is, and I'm going to just put this like this, the half circle, the D, is pi r squared. But because this is not a full circle, it's only half of a circle, get your answer and divide it by 2. Now, I'm showing divide by 2 as a fraction. I'm trying to get you used to that idea, right? That just means hit the division button. Now, in this particular case, let's try it out. The area of this half circle is a little D shape. You can use the pi button on your calculator, or you can use 3.14. Which are you guys going to use? You're going to type in 3.14? Okay. R, and then squared, is 1.75. And you can use either a square button on your calculator, or you can just enter it twice. Then divide by 2. I'm going to try this out too. I'll use the rounded numbers here, like the 3.14, not the 3.14159. And we'll see what we get. 3.14 times 1.75 squared. That means times again. Then I divide that answer by 2. I get 4.808, but 4.8, right, Destin?
Yeah.
Yeah. I'm checking with Destin to see, because I know he's worked it out ahead of time. Okay, now, what was it already? I forgot. 4.8 feet squared. Even though it's a circle, we're going to say feet squared. I want to just try sliding this up and down just to see if I can get rid of those blue lines. We've got some new ones now. Well, good gravy. I don't know what that's all about. Let's just see if that solves it. That doesn't solve anything. It just makes it look messy. Anyways, how do I find the total area? Hi there, just join on in. Here's what you need. Start now. We can ask questions later. Okay. Welcome aboard, Seneca. You grabbed one for both of you. Yeah, you did. Okay. I don't know what this is. It's a little better. Anyways, you see the total area would be the two little ones added together? I'm going to just put that as an aside here in blue or black. So this plus that, the total area is 4.8 squared plus, I'm going to add only 11.4 because 11.375. Why do I need to keep more decimal places? Unless I told you to keep a lot more. How's it going for you? With the washroom? Yeah. Feet squared. Now, what's this? I'm just not using the calculator, so double check my adding. 1 plus 4 plus that's 6. That's what you got, Mr. Martin, right? 16.2? Good. 16, okay, yeah, you have more decimals, 183. Now that's a first example here. I'm going to ask you what a strategy is for this. I'm going to just flip pages though, just to see if I can get rid of those lines here. Kind of, not always. I don't know what's going on with the board today. Anyways, With this second example, it's a similar one, but kind of the opposite way of thinking of it. To solve this, and I'll let you guys do it later on your assignment work time. What's the best way to think of this? Well, you're right back in here, Tia, but what does this shape look like except for a little doohickey on here? Like, what would you call this shape? It's almost a rectangle. Thank you, Kelly. This is a rectangle, eh? And we know, and you could find the area of a rectangle easy. Once you find that, you're going to subtract half of a circle. Does that make sense? And what's the radius of that little circle portion? 90 cut in half. 90 divided by 2, because it's the radius that you want. So 45 millimeters. Well, the area, pi r squared, right? Because you got to figure out what the full circle is, divide that by 2. But the area formula for a circle from the start of 3.1, that sheet, has that formula on there. You don't have to memorize the formula. It's pi r squared, half of a circle, they'll cut that answer in half. Don't try doing that right now, though. Let's just follow along. But I think if you understand that, you should be able to. Now, new skill. Find the surface area of a cylinder. I'm going to just bring something out here. We got a cylinder. Soup can, right? It's a cylinder. Pop can. Without any like curves in it. Still, like, well, I guess the sides are curved, but I mean straight sides. Not like, you know, a pop can has like a divot there, you know, stuff like that. No extra shapes to it. So let's say this is it. 90 millimeters radius. So the circle on end, halfway across it is 90 millimeters. 300 millimeters high, right? That's that. First, draw the net. Well, if you're not here in person, you can't see this. But if I pull off the lids, right, I've got 2 circles to do the area of. And then this. When I unwrap this, it's going to look like a rectangle, right? Hey, Braden. Better late than never. Grab a 3.2. Tony, hey there. So, okay, so you guys see what I'm talking about, right? You've got, when you unpeel that soup can, you've got a rectangle, just like the label of a Campbell's soup, right? And then the 2 ants to find the area. So this is going to be a little more, you guys can imagine what we just did? I just showed you how I unpeeled it, right? It was a soup can, now it's a rectangle with 2 circles. So to draw this, you've got the top, it's a circle. That's draw the net. First draw the net, yeah. Then you've got the rectangle. And then you got the bottom circle. Right? Just join in on the second page with us, guys. Surface area. Now, it's not a great drawing. It doesn't have to be. But we were told the radius here, I'm going to draw the radius in a different color. 90. So the radius, 90 millimeters. It's already cut in half. The radius is equal to 90 millimeters. Now, we have the height, 300 millimeters. What we don't have is the length of the wrapper here. That, you have to figure out something. does it make sense? No, wait. I'm going to go for a different color for this. Yeah, that'll work. Okay. Does it make sense that this distance around, I'm holding up the wrapper that I undid, is the same distance around that the circle was when I had it in there? It fit right, I made sure I had a perfect fit, right? That this distance right here is the same as the distance around that circle right there. Does everybody agree with that? Okay, because it had to, that's the way it worked. So this distance all the way around the circle, there's a name for it, it's called circumference. You remember hearing that? Circumference is a perimeter of a circle. The distance, if you were to walk around a circle racetrack, that's called circumference. And there's a formula for that too. And I would give it to you. Don't you worry. You want to write down, actually, if you have your 3.1 handy, too, maybe write this formula down not only on this sheet, but on the circle, both sheets. Just so, because that's the kind of sheet you take into that form, you take your formula sheet into your test. So the distance around the circle, the circumference, I'm going to just put distance around, I'll write out the full word because somebody will see this and that. What I'm talking about. Distance around a circle called the circumference. I'll just do C equals 2 pi r. No square involved. Now write that both on your formula sheet from 3.1's first page and this page. C equals 2 pi r. And then we'll get back to this in a second. Did you know that, Destin? You did, or yeah? Oh! Apology accepted. That happens to me. Great. Excuse yourself for a second and then explain what's happening when you come back in. I don't need to go into details, you know. Okay, so this distance right here is going to be 2 times 3.14 times the r, radius is 90. Okay, I'll backtrack because, like you said, what? You do know what's going on? Yeah. Oh, yeah. 2 pi radius. You're going to get a distance out of that. I get 500, yeah, I do, 565.2. I'm not going to keep the decimal too. I'm just going to say 565. I will, because you guys probably wouldn't too. I said I wouldn't, but I will keep that. Now, I'm going to pause again. Any questions about this one? Okay, because now you can do the actual area of the square. I'm going to put that inside the square. Or square, I said square, it's a rectangle. Is equal to length times width. So 300 times 565. 0.2 millimeters. You multiply that out, and you get this area. Then you got the area of the circle twice. I'm just putting that as square, or as a rectangle there, a rectangle, is that what you mean? Just so I know I'm doing that for the rectangle portion, not the circle portion. That's a big number. 69560 millimeter squared. Now, we still haven't figured out what the circles are, but we can. I'll wait till we're with me. I gotta make sure I get you in, Braden.